Now I'd like to introduce you, Angus. Many of you will have not heard this protocol. It's Chronicle, because it's from the MakerDAO family, and we are going to discover why DeFi has a problem and how we can verify that data. So I'd like to present you Angus from Chronicle. Woo!
Hello, hi. Oh, that's loud. Hi everyone, that was very dramatic. I'm afraid what I've come to talk to you about today isn't quite as exciting as that intro, but I'll do my best. So, as Dash said, I'm Angus Tookey, I'm here from Chronicle Labs, and I'm here to talk to you today about DeFi, and in particular a problem within DeFi, a data problem. So very quickly before I get into that, quick shill about Chronicle. You may not have heard of Chronicle. Chronicle is quite a new brand in the space. We only launched in September of last year, but you may know us by our previous name, which is Maker or MakerDAO. We are the Oracle core unit, or the former Oracle core unit of MakerDAO. And our sort of claim to fame, if you like, is we built the very first Oracle ever in June 2017 when we were launching the first iteration of DAI, the decentralized stablecoin. And then very recently in September, we spun out the Oracle team as Chronicle. Here we are. To this day, we're securing just over $10 billion worth of TVL, which makes us the second largest Oracle in the space after Chainlink. Yeah, we're continuing to serve Maker, Spark now, and others, and we're opening up Chronicle Protocol to the entire Web3 space for the first time. But I'm not here just to talk about Chronicle. I'm here to talk more generally about DeFi and about a problem that DeFi has, in particular with how it receives and consumes data. So how does DeFi receive data? Oracles is the answer. We have, some of you may know about Oracle-less protocols which have popped up, like Agena Finance, for example. But generally, the vast majority of DeFi relies on oracles to receive data and therefore operate. So before we get into that, let's have a quick look at how an oracle works. So this is how Chronicle works as an example, but this is generally how decentralized oracle networks work. So it starts with the data sources. I don't know if you can see that, if I'm in the way, sort of in the way for everyone, I'll move around. So it starts with the data sources, which is where the data originates. If we're talking about price data, that's probably like an exchange of some kind, maybe a centralized exchange like a Binance or a Coinbase. Could also be Uniswap, PancakeSwap, or something like that. And then the next stage in the protocol, or the Oracle network, is for validator nodes to pull that data from the source and effectively attest to the truth of that data. Right? So decentralized oracles work in a way where they have a consensus mechanism. So instead of asking one person, like what is the price of Bitcoin in US dollars right now, which is fraught with risks, of course, in Chronicle's case, we ask 22 people or 22 entities, each running a node, to give us that price, and then we use the consensus to understand the value, and then the median of medians to land on the average value that we actually push through. This is a really important step in an Oracle network, because without this step, without this sort of decentralized distributed nodes, sourcing the data from exchanges, etc., you're open to risks of centralization, so things going down if one party stops working, but also manipulation, right? And as we know, if oracles can be manipulated, you can drain or hack millions of dollars out of DeFi protocols, which we've seen happen in the past. The next step in the protocol is it goes to relays. Relays then kick it onto the blockchain, which is where a gas fee is then paid, which is why oracles can be quite expensive to run, because they're effectively paying gas every time they kick a new value on chain. So if we're talking about a price, every time we update the price of Bitcoin in US dollars, which as we know is changing all the time, oracles are paying in gas to put that on the blockchain. dApps that are using the oracle will then read that value off the blockchain and use it to, operate their protocols, basically. How do most protocols use an oracle? Quick example would be something like, Maker or Compound. If you go onto that protocol and you want to borrow some DAI, some stablecoin, you have to put up some collateral in order to be given these stablecoins, right? So you might put up 1 Bitcoin, say 1 Bitcoin's worth $60,000. The protocol needs to understand, okay, how much is this 1 Bitcoin that you've just put into my protocol worth, okay? So it needs the latest value, the latest price of that Bitcoin in order to know how many stablecoins to give you as the user. So that's like an example of how these dApps use it. And they get that value when we put it on the chain here, as I said. So that's how oracles work. But why do we actually need them, right? Why does DeFi rely so heavily on oracles? And the reason for that is actually inherent in blockchains. The way that blockchains work, they're distributed ledgers. Okay, they work as on a distribution of nodes, as we know, like Ethereum. I think just passed 1 million validator nodes, which is crazy. But there's no way for each of those nodes to know something all at the same time because they're all running separately. That's the whole point of the distributed ledger. As a result, if you have built something on a chain, or that chain as an example, let's say Ethereum, there's no way to get data from outside that chain into your product or dApp that you've built on that chain, right? Because that's just not how blockchains work. Anything that's happening on Ethereum, yeah, cool, you can access that. All of the RPC nodes or validator nodes or whatever can access that. But outside the chain, so on the internet or from another chain, let's say like Avalanche or Polygon or whatever, you can't access that data. So oracles act as the middleware or the bridge in the middle that allows for this data to come into the chain, be published on the chain, as we just established in the last diagram, and then, dApps can use it. Maker, Compound, Aave, whoever, they can use it. But there are some requirements with oracles. You can't just take the data and push it on chain. You have to have this sort of like quite complex makeup throughout the protocol, as we established, right? The validator nodes, distributed, decentralized, etc., in order to be able to do it autonomously and securely. Because you need these Oracle protocols to be able to work automatically. You can't have a human sitting in the middle, clicking buttons and pressing numbers on a keyboard to make this stuff work. Like, it needs to happen automatically based on thresholds, and it needs to happen securely, which is why we have these like consensus mechanisms built into the middle of it with decentralized Oracle protocols like Chainlink, like Chronicle, and others. So we know how DeFi consumes data. It's through oracles. We know why we need oracles. But what actually is the problem with data in DeFi? And the problem centers around 3 things. Gas is expensive for oracles, and therefore oracles are not scalable. Oracle networks themselves as protocols, they're not very transparent. And certainly a lot of the newer Oracle protocols and things are quite centralized. So touching on the first problem, gas expensive. Oracles are gas expensive. To give you an idea of how expensive oracles can be, in the last bull market at MakerDAO, we spent in a year just over $6.5 million updating our oracles. That's just updating the oracles. That's got nothing to do with anything else. No wages, no other operating costs. That's just updating the oracles. That's all gas costs. Most of that, of course, or all of that was on Ethereum. And to give you an idea of like what an oracle update looks like for people who like numbers in the room, I'll be very quick on this if you don't. This is an example of like what it costs every time to push a new price on chain for an oracle. In this case, this example is from Chainlink. Okay. So every time Chainlink pushes a price on chain on Ethereum, it costs $7.75 in gas. And these are based on this gas price, 16 GWE and $1,600 ETH. So we did this in the bear market when we were building. This is when we put this example up, as you can see. Because we're a lot higher than that now, which is great. However, take that into account, we're a lot higher. Gas is a lot more expensive, so that $7.75 is a lot higher already, right? Just based on the current state of the market. Updating the oracle only once per hour, so 24 updates per day, is going to cost you $186, right, on Ethereum, or $16.56 on a layer 2 EVM, right? Once you start multiplying that out by every day of the year, so times that by 365, or you start to get an idea of how expensive they can be. And then, if you understand that this is only for one oracle, so for one pair, like the price of ETH USD, for example. If you want the price of BTC USD as well, Matic USD, Mantle USD, whatever, each one of those is another oracle again. So multiply this by 2, by 3, by 4. And you start to see very quickly how oracles are so gas hungry and therefore very expensive to update regularly and accurately. There we go. So if we had an opportunity to bring this down, say by 80%, right, this is what the figures would look like. Drastic change. And actually, that's something that we've achieved at Chronicle quite recently. We've launched a new type of Oracle architecture called Scribe, which brings those costs down by 80% versus Chainlink. So, but what does that mean? Why does that matter? So as I said, it makes Oracle scalable for the first time. You can update your Oracle more regularly, right? Which means that the data that you're using as a dApp is more accurate, right? Because you've got the latest price. So say you're updating it every 5 minutes instead of every hour. It means that as Oracle networks and Oracle protocols, we can charge less, which is great, right? Great for everyone, right? More affordable oracles, access to high quality oracles. As a result, that means Oracle networks, high-quality Oracle networks that secure, billions of dollars, that secure big protocols like Maker, Spark, etc. They're now more accessible because we've brought our operating costs right down. So if you're a builder in the space, if you're hacking this, this week, and you've got a really cool idea, you may not be able to have access to like the highest quality oracles because, frankly, you don't have like millions of dollars of VC funding to support the costs, right? By bringing those gas costs down, we make them cheaper and more accessible. And finally, oracles are a terrible business model until you bring that gas cost down and you bring those operating costs down. Chainlink famously run their oracles at a loss. They make money in lots of other areas. That's not a problem for them. But they run their oracles at a loss because they have to spend so much in gas to operate them. So by bringing the gas costs down again, you open up a more feasible business model for oracles, making oracles profitable for the first time. The second problem with data in DeFi that comes through oracles is that it's not transparent. So oracles right now operate like a black box. You have the data coming in from the source, going into the Oracle protocol in the middle, coming out the other side, and the Oracle protocol itself is like a black box. You have no idea what is going on inside that protocol. So what does that mean? That means you have no idea where the data comes from, right? Where did these prices come from? What markets did they go to? Did they even go to more than one market? Who knows? How many sources of data did they use? And most importantly, which actors in the middle of the protocol, those validator nodes that we talked about, attested to the truth of that data? These are basically the people you're trusting to say that this data is true and correct. How was the final value calculated that the Oracle spits out, right? That price at the end. And more importantly, if there is a dashboard or something that an Oracle protocol has and shows you, how can you verify what you see on that dashboard is actually true and not just like a marketing exercise, right? Just like, brands and pictures and numbers and, make you feel good and warm and fluffy inside. Don't trust, verify, right? Like, how can you verify that? So here's an example of what you can see in the space right now. This is Chainlink's dashboard, right? So above this, it doesn't fit on the slide, but above this you have like a chart or a graph that shows you like the latest price, and then below it you have here. This is a list of all of like Chainlink's validator nodes, for example, right? So Chainlink is good in some sense that at least it tells you who these actors are. Like, who are these people who are basically like trusted with getting the data? You know who these are. That's great. And you know what they reported. This was ETH USD, for example. So we know what they reported. Great. However, there's no way to verify this. You can go to an Etherscan link here. Doesn't really tell you much. It gives you a contract. You've got no way of actually like matching the keys, the private keys of this validator, to the signature on the Oracle update. There's no way to do that. And also, it doesn't show you where data came from in the first place. Did they go to Binance and get it straight from the markets? That would be good. Or did they go to a data aggregator, like a Kaiko or something like that, and then is there inherent risks with using an aggregator? All of these things should just be like open and transparent, right? Like if you're a data user, you should be able to know these things and see these things. Here's Redstone, another example, a newer oracle in the space. They give you even less information. Again, it's just nice pictures and a chart and stuff, you know, great. Like, but really, where's the meat? Where's the real information? They don't tell you who attested to the truth of that data or who the validators are, who you're trusting in that network, because actually Redstone runs all of their own nodes. So they're a centralized oracle, and they operate their own validator nodes, and therefore they can effectively report any value they want. And here's PIF. Again, they don't show you where the data came from, where it's sourced. They do give you the private keys, which is nice, but you have no idea who runs those nodes. Again, PIF could be running all their own nodes. You have no idea. And again, that's not transparent. That is not what Web3 is about, right? Here's an example of Chronicle. So we have all of our validator nodes here, which you can see, which are run by big name brands. So you can, you know, the idea of that is that the trust is implicit. Gitcoin, Infura, Argent, Gnosis, 0x, DeFi Saver, MakerDAO, Etherscan, MyCrypto, the list goes on. We give you the idea of like, what did each of these validators report at any given time? So here's the timestamp. You can see that they reported 1554990. They're slightly different because they're reporting at different times. And then you can go a step deeper. You click on the drop-down, and you can see exactly where did they get that data from. They got it from Binance, Kraken, Bitstamp, Gemini, Coinbase Pro, wherever, right? You have the data sources. You know who attested to the data, and you know which of those validators was selected to basically which data was then used by that validator to push through to the other side. So every element is completely transparent. And then if you're a bit more technical and you actually want to like trace the private keys that we used in the signature for the Oracle update on chain back to the validator that attested to the truth, you can do that. You click the verify button, you effectively run the same computation in your browser that the smart contract does to check, and if it checks out, it goes green, you get a nice little confetti of Chronicle logos. If it doesn't, it goes red. And we actually made this box editable. You can try this on the chroniclelabs.org dashboard, and you can change a value. So we actually changed the age value slightly differently there to make it happen a second earlier. And as you can see, the hash changes, and then it doesn't match the key anymore. And that shows you that what the dashboard is reporting is false. And the third and final problem is about Oracle networks that are centralized. We're seeing a rise in centralized Oracle networks more recently. And the reason that they're popping up is because they're trying to find other answers to some of these other problems that we talked about earlier in the presentation, right? They're trying to find ways to bring costs down. They're trying to find ways to deploy faster and on more blockchains and more quickly. But they're doing it at the cost of decentralization. But why does this matter, right? Decentralization, buzzword, centralization, like who actually cares, right? Well, in the case of Oracle networks, it's really important because it creates a single point of failure, which basically means that data network, you could have, in this case, centralized validators, right? We already talked about Redstone as an example of centralized validator set. If you run the majority of those validator nodes, you can report any value you want. I'm not saying that Redstone do this. I'm pretty sure that they don't. But the risk is there. The risk is there, and that's a problem. That's an issue, because if a hacker were to get control of the majority of those validator nodes, they could report that Bitcoin's worth $1 million, for example, right? And then drain every DeFi protocol that's using that oracle. Second way that you can have centralization in oracles is if you're using a single data source. One data source, or a centralized data source, if you like, is a huge risk. And this is why it's so important to know which data sources your oracles are using. Because if they are using one, you have like a Mango Markets style problem, right? Mango Markets had an option on their protocol where you could put up the Mango token as collateral and then borrow stables and other tokens as a result, right? They were using a single pool on a DEX as their data source. Someone worked that out. used a flash loan, got hold of millions of dollars, used that to affect the liquidity pool by basically pumping in a load of liquidity, pump the token price up to like, thousands of dollars, then use that to drain the protocol. Because the protocol was like, oh, Mango token's now worth thousands of dollars. You've got 1 million of them. Great. Here's, $10 million, right? So that's why single data sources are also really, really dangerous points of centralization in Oracle protocols. And we need to avoid them. So more decentralization, more distribution of your nodes, more distribution of your data sources equals more security. Why? Because hackers need to gain control of more nodes, of more sources, right? And it's the same way Ethereum works. Byzantine fault tolerance is another way to refer to it as well. But not all decentralized oracles are equal. Some oracles are decentralized, but then they only use, for example, 3 validator nodes. That's decentralized, but it's not really very safe, right? Because you only need to get control of 2. If there's 22, then that's very different, right? You need to get control of 11 or 12. Why do they do this? Less validators equals less gas. So they're really just trying to keep their operating costs down, but at the cost of security. And people don't know this, right? Unless you know how to look on chain and actually verify this, you don't know this. So not all decentralized oracles are equal in that respect. And if the thing works, decentralized validators are really important, and at Chronicle, we take that to the next level. Here is a list of all of our validator, people who are running our validator nodes, basically. So we don't just have a distributed set, which is really important for security, as we said. We also do it with some of the biggest and best-known brands in the space. So the trust that you put in these brands is implicit in Chronicle as well, because these brands effectively need to get hacked in order for Chronicle to get hacked. And if these brands get hacked, I think we've got a bigger problem than just what happens on Chronicle. So just to wrap it up, because I've just gone over time, when you're choosing oracles, you need to think about all of these things. You need to think about where are the data sources, how decentralized is their validator set, who are the validators, who are the people who are testing to the truth of the data. All of this stuff is really important because oracles, as we established, are at the core of DeFi. They are integral to how DeFi operates. So if you're building a DeFi protocol, remember, your protocol is only as strong as its weakest link. So pick your oracle very carefully. And that's it from me. I think we're at the end there. Yes, thank you so much for sitting here and listening to me for over 20 minutes now. Really appreciate it. Hopefully I was able to help some of you understand oracles a bit better and the risks of designing oracle protocols. If you want to get in touch, you can scan the QR or hit us up here on any of these links. I've been Angus Tookey from Chronicle Labs, and it's been a pleasure. Thank you. Cheers.